Hey everybody, Mr. Colella here. Going to try to quickly talk to you about compound probability. So first of all, what is that? It deals with compound events. Compound events are when more than one event is happening. So far we've really only talked about one thing happening, like a spinner. So I could spin that spinner and I could ask you, what is the probability of landing on yellow? And you would hopefully say to me, well, there are 4 sections and yellow are only one of those 4, so you have a 1/4 probability. That is true. But what we're looking at now is times where we say, okay, you're going to spin a spinner, but then you're also going to flip a coin. So I might ask you, what's the probability that you will land on yellow, but then flip and get tails? So it adds a little bit extra layer and a little extra dimension to this, so let's talk about how we handle that. So the first thing you need to do is you need to think about what the sample space is of the compound event. Now, a sample space is the set of all possible outcomes for a given situation. So if I'm spinning a spinner and flipping a coin, there's no longer just 4 possibilities. When it was just the spinner, I had red, yellow, green, and blue. That was it. But now I have red with a head, red with a tail, yellow with a head, yellow with a tail, blue with a head, blue with a tail, and so forth and so on. So it's a lot more possibilities. Now, first of all, I'm going to give you a little bit of a hint. You can always know the total number of possibilities simply by multiplying the 2 things that are happening together. So, for instance, what I mean by that is that when I spin the spinner, there are 4 possible things I could get, 4 different colors. When I flip the coin, I have 2 things I can get, heads or tails. All I have to do is multiply those together. 4 times 2 obviously equals 8. So I have 8 different combinations that I could possibly get here. Okay, so always remember that if you take each of the events that are happening, think about how many different outcomes they have separately and multiply them together. It'll tell you how many outcomes they have as a compound event. Now, when you're figuring out compound events and looking for those sample spaces, there's 3 different ways that we typically look at to do that. They're a tree diagram, a table, and an organized list. Each of them has kind of their own times when they're good and times when they're not so good. As you do this more and more, you'll find hopefully a comfort level of when you should do a tree diagram versus when you should do a list and so forth. Okay, so let's just look at each of these 3 quickly. The first one is a tree diagram. My advice is to use tree diagrams when there's more than just 2 things happening. So the example I'm going to give you in a second actually has 3 different events happening. Anytime you have more than 2, I would typically use a tree diagram. Okay? So we're going to talk about choosing ice cream. Let's say you're at a party. You can choose either chocolate ice cream or vanilla ice cream. But after you choose your ice cream, you need to choose a sauce. So you need to choose either hot fudge or caramel to go on your ice cream. And then after that, you need to choose a topping. So you need to choose either sprinkles, cherries, or walnuts. Now again, I want to point out to you, I can look at this and I can say, okay, there's 2 ice creams, 2 sauces, and 3 toppings. 2 times 2 times 3 equals 12. There's going to be 12 total combinations, okay? But in order to answer questions, I need to know what those 12 combinations are. Because if I say to you, well, what's the probability that you're going to have chocolate ice cream with cherries on it, you need to know how many of those 12 combinations have that, chocolate and cherries. So here's what we do. It's called a tree diagram because in the end it's going to look like a tree. It's basically going to have that tree shape at the end, okay, almost like a Christmas tree. And the reason it's going to have that is because what we're going to do is we're going to start at the top and we're just going to branch off every time there's an event, okay? So in this case, an event is every time I make a choice. So the first choice is, do I want chocolate ice cream or do I want vanilla ice cream? So I am going to say, okay, I can branch off and I can go to either chocolate or I can go to vanilla. I'm just going to abbreviate those to make this quicker. Okay. After I choose an ice cream, I have to choose a sauce. Now here's the thing. It doesn't matter if you chose chocolate or vanilla ice cream, you still get to choose a sauce. So I have to branch off of both of these with my sauce options. Again, I'm going to abbreviate. I'm going to just say HF for hot fudge. I'll do C for caramel. And then same thing over here. So it doesn't matter. I have already 4 possibilities, because if you look, I have, you just kind of follow the path. Start at the top, and I could say chocolate ice cream with hot fudge. Go back up to the top, I could have chocolate ice cream with caramel. Or I could have vanilla ice cream with hot fudge. Or vanilla ice cream with caramel. But I'm not done, am I? I've got toppings to choose. Now there's 3 toppings, so for each of these, you need to branch off 3 times. So right now I'm looking at chocolate ice cream with hot fudge, and then I'm going to choose one of 3 toppings. So I'm going to just do S for sprinkles. I'll do CH for cherries, because I already used C for caramel, and W for walnuts. But I could also have those toppings on any of these other combinations. So sprinkles, cherries, walnuts. Sprinkles, cherries, walnuts. Sprinkles, cherries, and walnuts. Now whenever you finish a tree diagram, what you want to do is you want to look at the bottom row right here. Now if you look and count these up, if I just go across sprinkles, cherries, walnuts, sprinkles, cherries, walnuts, and counted them up, there would be 12. Remember we said you'd have 12 combinations. That last row will always show that total amount. So if you remember, my question at the very beginning was, what was the probability of having chocolate ice cream with cherries? Well, I'm going to look at this and I'm going to say, alright, well, I could have chocolate with hot fudge with cherries, but I could also have chocolate with caramel with cherries. So the answer is there are 2 out of 12 possible combinations, which simplifies to 1/6. So choosing chocolate with cherries, my probability is 1/6. Okay, that's a tree diagram. And again, you should hopefully notice it looks like a tree when it's all said and done. At least that kind of Christmas tree type shape. Alright, a table. A table I would recommend using when you have only 2 events happening. It's a quick way to kind of just cross-section 2 different things. If you've ever played the game of Battleship, it's going to kind of look like that when we work on it. So you're basically going to make a table like this. I'm going to fill in the different things that I have. Now, really quickly to talk about how many combinations we're going to have. I have 6 sides of the dice, and I have 4 colors on the spinner. 6 times 4 is 24, so I should have 24 total different combinations. And when we finish, you'll see that that is correct. Okay, so when I look at this, I could again have any of 6 numbers and 4 colors. So I'm going to fill it in like that. Okay, so you can see right across the top here, I have 1, 2, 3, 4, 5, and 6. And on the left-hand side, I have blue, red, yellow, and green. And all I'm going to do is I'm going to fill it in, and I'm going to say, okay, I could roll a 1 and spin blue. Or I could roll a 2 and spin blue. Or roll a 3 and spin blue. 4 with blue. 5 with blue. 6 with blue. And then basically say, okay, well, you know what? I could do the same thing, but I could get reds. So 1 red, 2 red, 3 red, and so forth. And you're going to go ahead and fill in this entire table. Now, I referenced Battleship, if anyone's ever played that before, and that's because when we fill it in, we're basically saying, hey, you know, here's yellow, and here's 1, so I just see where they meet. Okay? So, it's kind of like the game there. So, 1 yellow, 2 yellow, and obviously I'm just using the first letter of the color to speed us up. Oh, that should be a 4, my mistake. 4 yellow, 5 yellow, 6 yellow, and then the green. So 1 green, 2 green, just do it quickly, 3 green, 4 green, 5 green, and 6 green. So I already know I have 24 combinations. There they are. You can see them now right here. Okay. So now when I ask you questions, you're going to look and see of those 24 combinations, which ones satisfy what I'm asking for. So what if I asked you, you know, what is the probability if you roll a 4 and get red? Well, 4 with red is right here. And that's only 1 out of 24. So that would have a probability of 1/24. Or I could say to you, what's the probability of, let's say, getting an odd number with red? Well, odd numbers are 1, 3, and 5. So I could get a 1 red, a 3 red, or a 5 red. That's 3 possibilities out of 24, which simplifies to 1/8. So again, we can figure out how many total combinations there are pretty quickly, but we need to actually make the table to see what those combinations look like. The last thing you could do is just an organized list. This one I would just save for things that seem pretty straightforward, or things that are just pretty quick and you can't really mess up. Sometimes people try to make a list for everything and they miss combinations. So again, I would keep this only for the simplest of problems. An example would be like, say, when we're flipping a coin. Often you will see questions where they talk about flipping a coin multiple times. So this one we're going to look at, what about flipping a coin and getting heads twice in a row? Well, if I'm going to flip a coin 2 times, there's only 4 possibilities that I can get. And I know that because when I flip this coin, there's 2 things, heads or tails. And when I flip this coin, the second one, heads or tails. So again, 2 times 2 is 4. So I know I have 4 possibilities. Those 4 possibilities are simply head with another head, head with a tail. I could get a tail first and then a head, or I could get a tail and then another tail. Those are the only 4 combinations that I could get when I flip a coin twice. Okay? So the problem that I put there was, what's the probability of flipping heads 2 times in a row? And you should hopefully see that's this one right here. So that is 1 out of 4 possibilities. So flipping a head 2 times in a row, that's 1/4, which is 25%. Okay, I could mix up those questions a little bit. I could ask some slightly different things. So let's say I get rid of this. What if I said to you, maybe what's the probability of getting at least 1 head? Well, that's all 3 of these. So 3 out of 4 would be the probability of getting at least 1 head. So again, we have some multiple ways here to kind of figure out your sample space, which is the total combinations and what they look like. You need to figure those out and then just see what you're looking for, how many out of the total there are. Okay? I hope this helps. You're going to look at some compound events this week. Good luck.